Okay, good morning. How are you today? All good? How was this morning? Yeah, awesome. Yeah. And what did you do? In the rain. Oh. Yeah, the weather is tricky these days. Anyway, we always prefer our math lessons to be in the morning so that we are clean in our minds and we go from there, inshallah. So let's start our lesson. Today's topic is another type of functions. So we discussed last lesson, if you remember, what did we discuss, Mark? Yeah, linear functions. So we discussed linear functions. Okay? What did we say about linear functions? Yeah, it's a function in one unknown only. So for example, y equal function of x and constant k. Okay? So we called it linear because its graph shape, the graphic shape, is straight line. Straight line. Like this. So these are the axes. Yeah? How it looks like. To the right or to the left, the slope. Good. Do you have something to add? Yeah, it doesn't matter because it is according to the sign of x. So it is something like a straight line like this. So today we are going to explain the higher order functions. So the functions that have more than one value as a solution. So it is not a function of x, it is a function of x squared. So higher order functions, and they are nonlinear functions, and they are function of x squared and x, good, yes me, and constant k. This is very good. I'll just tell you about the graphic shape of this function and what it is called, and then we'll think together what this function is used for. What is the practical application of this function in our lives? So it is called parabola. Parabola is the shape, the graphical shape of the function. It's called parabola, and the function is called parabolic equation. Okay? It takes this shape. So if these are the axes, it takes something like that. Okay? All like that. Other direction. And of course we can move this curve. We can move this curve to whatever place. Okay? So now I'll put for you a post-it, and as we are used to, I'll collect the post-it from you after you are thinking together in your groups and telling me what are the practical application of this function. Okay? We discussed before how to think about a practical application for a function. We see the shape of the function and that there is an independent variable and a dependent variable, and according to the relationship between these variables, we can expect what is the application that takes that shape. So I remind you, when we discussed the straight line, we said that this is, can you remember, Mark? Awesome, perfect. We said that this is as the relation between the speed and the time and the distance. That the one can drive on or can walk, the relation between them is a straight line. Now, take this post-it. Yeah, first group. Yeah, awesome. Second group. Yeah, it's okay. Now, think what is something that takes in its activity this shape. Something like this, and then again like this. Or something like this, and then again like this. Can you see? Can you see the different shapes? So it is something like a curve like this, and I'm not saying increasing or decreasing, I'm just telling you the terms and something like this. Okay, go. First group, perfect. Yeah, I'll be walking between the groups. You need to think more. Why it came like this? Yeah, it is a good application. It can be. Yeah. Okay, this is your expectation, but why? I need you to think deeper than this. Okay? First group. Good example. Okay, let's now see what did you come up with. So, Mark, you are the leader of this group. Tell me. So, throwing stones. Stones. Yeah. Yes? Yeah? Perfect. You said projectiles. Another example? Yeah? Yeah, no. Okay. Driving a car. What else? Yeah? Okay. Yeah, pushing. What did he say? Yeah, pushing along a ramp. What do you mean by this? Pushing something along a ramp, going and returning back. Pushing along a ramp. Okay, that's all. Okay, so I just need to remind you that we are discussing functions. So, whatever the dependent variable is a function in the independent variable, it can be represented by many shapes and many functions. So, in our practical life, we will find a lot of practical applications for this function to be solved. So, let us say, what did you say in your examples? Okay, so yeah, projectiles is correct application, and also anything that takes the shape of curve in its motion. Anything that takes the shape of a curve in its motion. So the very famous application is when we need to decide the time that a rocket can reach when it is thrown from the top of a barn. So this is a barn, okay, with a top H from the floor, and the the rocket is launched from here, is launched from here. So the motion of the rocket takes this shape. So at a time t, at time called t, the height of the rocket is given by the function height equals negative 5t squared plus 10t plus 20. Okay, so can you see here the height is that value, height 1. Here it is different, height 2. Okay, here it is different also, height 3. Here it is totally different, height 4, and so on. And so on. So this is how the value of the height changes with time. So if this is the time axis, so after 1 second, after 2 seconds, after 3 seconds, after 7 seconds, and so on. So the time is changing and the height also is changing. It's according to that function. So the rocket and any projectile, so the bullets and any other projectile, changes according to this function. So this function in our lives has many applications. This is the quadratic function and this is the parabolic shape of the function. Let us now discuss how this function is written and how it is solved. So at the beginning of the lesson, we said that the quadratic function takes this function. It is a function in x squared and x and a constant. Okay? So let's now see how this function is shaped. So we can say x squared f of x equals x squared plus x plus 7. We can say 2x squared minus 3x plus 19. We can say half x squared plus 5x minus 3. We can say negative 2 over 3x squared minus x. So it is a function in x squared and x. This is the quadratic function. Now, I need you, by throwing our stress ball, to tell me the formula, the general formula of the quadratic function. Okay? Mark. Yeah? Constant x squared plus constant x. Okay. Now, Yasmin, tell me. Function of constant x squared. Alright, as you said, and x. Okay. So I need you to think deeper and deeper. How we shall write this formula, and then in your groups discuss together. I will elect from each group one of you and tell me about the final formula of the quadratic function. So that next lesson we will be discussing how to solve this equation and how to factorize this function. Okay, go in your groups. Okay, that's it? Yeah? Okay, awesome. You did a good job. I can see that you are thinking and you are trying to find the formula and you are asking yourselves why this formula is coming and how we can derive the formula. So the three leaders kindly tell me, yeah, please, from all of you, elect one just to tell me the formula. Okay, Mark, tell me. Constant x squared, constant, another one, yeah, tell me, constant 1, constant 2, x plus constant, this is, awesome, you got it, but we use, instead of k1 and k2 and k3, we use ax squared plus bx plus c is the function of x, and we call this the quadratic function and the parabolic function. So now in this lesson we discussed the parabolic function, the quadratic function, the higher order function other than x, the nonlinear function. All of these names are one of the names for the quadratic equation, and we discussed some of its practical applications in life, and we thought of getting or deriving the general formula of the quadratic function, and we knew how this came up, and we gave an example for the rocket and the projectile. So next lesson we'll be discussing how to solve this function. So please, in your worksheets, try to solve the small quizzes and send to me over our student forum so that we can discuss further and further until the next lesson. Thank you for your listening, and thank you for your cooperation inside the classroom, and I can see you next week.